Alright, we need to find the derivative of this inverse secant function. This inverse secant function can also be written as an arcsecant. And we learned in this section that the derivative of an inverse secant function looks like this. That's the derivative of the inverse secant of just x. But if we have a function of x as the argument of our inverse secant, let's call that function of x u, then the chain rule says that we need to multiply that result by the derivative of that function u. So let's find the derivative of our given function. I'm going to start with the 1 over absolute value, and inside that absolute value we're going to put the argument of the inverse secant function. Then we're going to have a square root out here. We're going to take that argument of the inverse secant function and square it, and we're going to subtract 1 from that, and all of that is going to be under a square root. Then the chain rule says we need to take this result and multiply by the derivative of the inner function or the argument of that inverse secant. Fortunately, we know how to find the derivative of 7 times the natural log of 2x. I'm going to copy all of this down. I'm going to leave the 7 outside. The derivative of any natural log function starts with 1 over the argument of the natural log, but then this up here is another composite function. We have an inner function of 2x, so the chain rule says that we need to multiply this result by the derivative of 2x, which we know to be 2. This 2 then is going to cancel with this 2 in the denominator, and that's going to leave us with our result. In the numerator, we're just going to have a 7, and in the denominator, we're going to have all the same stuff, except we have this extra x now. And I think that trying to simplify that answer is not going to lead us anywhere, so I'm going to box that thing up. We're going to call this answer good, and we're going to talk more about derivatives of inverses of functions in the next problem of the day. I'll see you there.